Doug, thank you very much for the introduction and good morning to everybody here. I prepared, let's say, a 25-minute speech, and I would like to make it a little bit more interactive because I don't want to repeat the stories which you already know, but I would like to give a little bit an insight from somebody who's working with its passion from a raw material industry, delivering plastics to the society, and is convinced about, I think that was my title, that we can save energy and protect the planet if we build the right innovative solutions by plastics. And it is mainly about applications. I'm not talking about the polymetallic material, it is about plastic applications. So a little bit about Bayer. Most people in Germany know it because of a soccer team. In the world, it is more known to the aspirin, which was invented by Bayer. But not only aspirin was invented by Bayer. Everything what you see in your life is somehow related to products which we have a relation to, or sometimes we invented them even. Urethanes have been invented by Bayer, polycarbonate, and we having a life science company and a material science company under one roof. The life science is the aspirin and the healthcare division and the crop science division. And material science, which I'm representing, is then taking care of contributions to the automotive industry, but for example, also the coating of the bird's nest in Beijing. Talking about plastics, we have done that before. I think for everybody here, it is inevitable that you cannot live anymore without plastics. It's a given that you have to have them, but you have to implement them at the right point. And you have to look for the right applications. And what I always like to say also in our R&D facility, they have been invented only about, let's say, 120 years ago. And we are still working on innovations with plastics, so they are not static. It's not that it is finished. We are continuously improving the properties and also the production of plastics, and that is something what we have to do together. And for us, from the chemical companies and a producer of plastics, it is extremely important that our applications are sustainable, because we build these big plants, and we want that the material which comes out of these plants is used also in the future and is not harming the planet or the environment, it is contributing. And I'm trying to give you a few examples then here. First, and I think that is also written here, that we have as a feedstock, as a raw material, sources which is from crude oil or from fossil fuels. But if you look at the use of fossil fuels, most of it, like more than 90%, is actually used either for making electricity or run your car or making energy consumption. So we're talking about a very small share of the fossil fuel which is going to be in plastics. And once we're doing that, the difference is that once you produce 1 ton of the plastic, during its lifetime, it really can save carbon dioxide consumption, because plastics are more lightweighted, they have a lower density. So if you do something from plastics, you can save already the planet. And what we in the chemical industry try to do is that we reduce even our own carbon footprints. So by producing nowadays 1 ton of the product, we use less energy and we produce a product, hopefully in an application which lasts even longer. And I will point out a little bit later also these applications. So this dynamics is not seen really to the end consumer. And we are here in a B2B business. I'm not selling to the end consumer like my colleague from healthcare who's selling aspirin. I'm dealing with people who are in a tier supply chain to the automotive industry. And this message somehow gets a little bit diluted or lost into that. So saving carbon from plastics is for me a given. And the people who are working with me in Shanghai in our innovation center, we are continuously striving to improve that. I would like to take now 3 examples from the plastic industry where you find them, because we can all talk about packaging. Everybody somehow lives or owns a house, and everybody is doing also transportation. And just only to give you a little bit a hint what impact plastics will have there is indicated here. So 50% of all food is packed. Actually, I think the EU Plastics was mentioning that if you don't pack food, it rottens. And on the world, there is still the biggest problem of food supply is that it is not packed. So in developed countries, like here in Hong Kong, or also in China, this is not really a problem. But specifically in the countries where you have scarcity of food, the packaging is sometimes the biggest problem. And once you're doing the packaging, then you don't eat the package, you eat, of course, the food, and you want to make sure that you are not transporting too much weight for the packaging. And everybody knows that glass is more heavier than plastic, and it is not as easy to be transported as it shatters. So plastic is a natural component for making packaging. It has certain properties for barriers that it doesn't rotten. So oxygen or carbon dioxide does not penetrate. There are many, many good things, and that's why I think you cannot do packaging without plastics, but later I will come to the point of the problem of that. What we need as a raw material supplier is we sell properties. I'm not selling packaging. I need raw materials to sell a property. And if I get in a very good specification, when I get polyethylene terephthalate PET bottles back, I can do something with this which is different. For example, here you see that we combine PET with our polycarbonate to make a TV frame, which is then flame retardant and better than the old TV frames. Or you make a fender in a car. So this is something what you don't see if you have your packaging or your water bottles or your plastic, which you normally put then in a bin, that this becomes something special. Yesterday evening I mentioned this. I was driving in a train in Switzerland, and there was a sign on the window, please don't throw out bikinis. It's like, what is that? And then there's this little note that your PET bottle will most likely be recycled to become a textile. And then it is clear. I mean, throwing out PET bottles out of a window in Switzerland is not really nice. And Switzerland, anyhow, is a very tidy country. But making it a little bit more appealing, not throwing out a bikini is anyhow what you wouldn't do, is a story how you can bring this recycling loop back. Talking a little bit about construction. Here in Asia, it is a little bit different, but in Germany, they build houses for 80 years. I learned in the United States, it's about 25 to 30 years. Maybe here in Asia, it's something in between. So if you invest in a house, you put a lot of value already on that, and then you have to run it. And one point is the energy consumption in a house. So if you look then, and you have built it, it is at a certain point impossible really to change it. So insulation material from the basement, once you've done it, it's done, or you haven't done it. So here you have, whether it's expanded polystyrene or it's polyurethanes, the pipe insulations, all these things, even if you have a window and you mount the window, you have to insulate the framing. Here you can invest something which is by the classical material which you know, concrete, stones, metal, glass, by far not that contributing to your energy consumption of the house. A very simple study is for example, your refrigerator. If you take your refrigerator, and I'm a little bit older than most of you, but I remember my parents had refrigerators. The walls have been thick like this, and I think there was glass wool inside. And the compressor was running all day, all night. Nowadays, you have refrigerators which have maybe 2 centimeters or 1 inch of thickness. And the foam inside is a polyurethane foam which holds the inliner with the outliner together. It works like an adhesive. This foam has a certain cell size. Within the cell size, you have a certain gas. The gas is actually something which transports the energy from outside to the inside. If you design the cell gas and the cell walls and the size of the cell in a proper way, you can have an optimum of cell size. If the cell is too small, then everything, the energy goes through the walls. If the cell is too big, you have too much cell gas and the energy can be transported. So this is some kind of science which we are optimizing for a refrigerator, and the new ones which you have now on the market can save you 60% of your energy bill compared 15 years ago. So this is something, it's still a normal refrigerator, but these are innovations which are continuously going on. And imagine you apply this kind of foam to your heat piping or your water heater or other stories. Another topic which I would like to touch is transportation. As I started with Bayer 1990, I like this picture. That time I bought this car, Golf, which was a very nice car at that time. And it had 10% of plastics inside. It had a weight of 1 ton. And of course, it developed. So nowadays, if you sit in this car, you feel, okay, it's an old car. If you take the new Golf, you feel like you're sitting in your living room. And everybody was talking about that we are reducing weight in cars. But if you look at the car, it is more heavier than the one which we had 20 years ago. But still, we have now 20% of plastics and polymers inside the car. And it would be impossible to have the weight saving if we wouldn't have entered these plastics that you can compensate for your window lifter, for your stereo system, for your whatsoever is built now into a car. So by this, we were able to reduce significantly the fuel consumption of car, and the carbon footprint of this transportation goes on. If you continue this story for the future, or I have to add one story again, because I'm with polycarbonate. This, for example, are headlamps made from glass. And they were thick, because they had to be thick, because a stone would shatter them if they would be thin. These headlamps are made from polycarbonate. It doesn't shatter if you try to break it. I remember a party at Bayer in 1994 when we got the regulation done that we are allowed to use polycarbonate instead of glass for headlamps. And everybody was dreaming that soon every car will be made from polycarbonate with headlamps from polycarbonate. It took 10 years, and it was like that. 10 years looking backwards is like nothing. 10 years looking ahead, everybody was thinking we are lunatics. And I think the spirit which I sense here also is, if you are going to be on the right track and have the right vision, it will be done, but it takes time. So the next story, what I see is airspace. I mean, we are building airports everywhere, in China specifically, and we are still using classical materials, magnesium and alloys in air freights. We see a possibility of bringing composites together, aluminum or magnesium together with polymers. Former times we were always thinking that this is plastic world and this is metal. The future will be a combination of both. So that's why I think we are doing a lot of good things for plastics, which you can read here. And the 21st century is really this, the century for this key material. And we have to do it in the right way. And that is why we need help. And the plastic industry, the producers like us, will be not the only one who is responsible to resolve the problems. And as I prepared for this meeting, I learned that 80% of the marine litter actually comes from land. So this is where you can eventually better stop it than collecting it in the ocean. And there is what I see, or what we see really is the problem, that you have to have the right waste management. And this is also not done overnight. Coming from Germany, I know that in the 90s we put in regulations, and then everybody is looking also for short wins. And I remember the discussion that with this yellow dot, which we have, the gelbe Punkt, that people collected then the money, but they were not really taking care of the plastics because there were not the real logistics and the separation and the cleaning of that. But it took 10, 15 years, and we are now having an own industry about recycling, which is profitable in Germany. And it is not the producer of the plastic. So it's not the BASFs, the Dows, the Bayers. It is an own industry, and I think we will learn about this today also. So all in all, I think plastics by itself, even they are detectable by every child, do not pollute. They pollute, of course, if you waste them somewhere. But this would do also metal, this would do lacquered wood, this would do everything what you misuse. The only thing is, if it is plastic, it's really easy to be found out because it is staying. And it is made to stay, to be sustainable. Imagine if you have a biodegradable headlamp. It is something which is not good. I'm in favor of every biodegradable product which is used for a limited lifetime. And we are also working together with that. We are having polylactic acid, which is a biodegradable polymer, in our program. And we are going to work together with this and recycle them even. But in the end, and here I come back to my first slides, is you have to use the energy content. It comes from fossil fuel. So in the end, even you recycled it 10 or 100 times, you should use at least the energy content in a proper way. That is also something. It's not burning it up that you are not having it. You have to do it properly. And here I would like to add another vision which we from a chemical industry have. We have a cooperation in Germany with the University of Aachen and RWE, which is a plant supplier, where we take carbon dioxide, which comes from a carbon plant, a power plant, and we make polymers out of that. Because CO2 is a molecule which contains carbon. And if you have the right catalysis and if you have the right chemistry out of that, you can bring it back into polymers. At this moment, we are studying this to be in a pilot plant status. If this really results into something which can be applied, it will also be opened for more applications. So with science and with these technologies, we think the future of plastic is a given if we behave and run it the proper way. And I hope that I caught up some time now, because I have to give this forward statement because I spoke about the future, and that is then always for our stakeholders something very dangerous. And that is why I like to finish now here my presentation. I thank you for looking at me and listening to me. And I don't know if I hit the right nerves, but maybe I have some time to answer you some questions, which I hope then illuminates this. Thank you very much.